Hey, welcome back, math friends. Today's lesson is lesson 7.3.5. This is the second half of chapter 7, lesson 3. So make sure you write that at the top of your page in your next page in your math notebook. We're solving linear systems of equations, part 2. Remember, a system of linear equations, or just a linear system, two or more linear equations that share the same two variables, and the goal is to find the value for those variables that make all the equations true at the same time. Now, in the last lesson, you learned how to solve systems using linear combination or elimination, which requires the equations to be written in standard form. Standard form, ax plus by equals c. That's standard form. But not all linear equations are written in standard form. So in this lesson, we're going to learn to rearrange the linear equations so they are in standard form before we solve the system. Let's do it. All right, here's this system, and we're going to solve it. Now you'll notice 3x plus 2y equals 8, that's in standard form. But the second one, 2y equals 12x minus 5x, or 12 minus 5x, that's not in standard form. So we've got to put it into standard form first. So let's do that. So 2y equals 12 minus 5x. We've got to get that x term to the other side. So I'm going to add 5x because that's how I can move it. Got to add it to both sides. So that cancels out over there. And on this side now I have positive 5x plus 2y and just 12 on that side. Now it's in standard form. Yay, right? Standard form. So now we have two equations and they are both in standard form. So let's write them both again. All right, magically they appear. So we're going to choose the variable to eliminate from both equations. So step 1, choose the variable. Now this one looks pretty straightforward. I can do less work and get rid of the y variable. How? Well, let's do that. So that takes us right on to step 2. In step 2, I'm going to multiply one or both equations by a number to get the coefficients that are opposite. If I multiply either one, but I'm going to multiply the bottom number by -1, all the variables in that equation will change. All the terms will change to their opposites. So the top stays the same, but everything in the bottom equation, because I'm multiplying by a -1, everything will change signs. And so I end up with negative 5x minus 2y equals negative 12. Now the cool thing about that is when we go to combine these two equations now using linear combination, I will truly be able to eliminate the y terms because I have a positive 2y and a negative 2y. And they cancel out. Now I have 3x and negative 5x on one side. When I combine those, I get negative 2x. And 8 combined with negative 12, I get negative 4. Now the last step to solve for x, divide by my coefficient, which is negative 2. And now I have x equals negative 4 divided by negative 2. Negative divided by negative is positive, positive 2. Now I know what x is. X is 2. Now all I have to do is substitute that x back into one of the other equations. So as you can see, sorry here, this was step 3. Now I'm going on to step 4. I'm going to use substitution. So x is 2, so rewrite one of those equations. 3 times 2 plus 2y equals 8. All right, 3 times 2 is 6, plus 2y equals 8. I have to subtract 6 from both sides. So now I have 2y equals 8 minus 6, which is 2. Divide both sides by the coefficient of 2, and I have y equals 1. Now I have my two variables. I have solved for both variables. I have an ordered pair of 2, 1. And we know that's going to be true, but you always want to go through and do step 5, and that is to put those numbers back into the original equations, right? Put those numbers back into the original equations to make sure that they are both true. And I can guarantee you that they are on this case, but you always want to double check your own work. I'm just trying to save video time. Now let's try a real world problem. You're planning a birthday party for your 8-year-old cousin, and you have the party at Chuck E. Cheese. You can have the party at Chuck E. Cheese for $8 per person, plus $30 for party hats and a small cake. Taco Time charges $12 per person, plus $14 for a large cake. So how many children C would you have to invite for the total cost T to be the same at both places? Oh, wow. And what would that total cost be? Okay, so we've got lots of information here. It's $8 per person plus $30. At Taco Time, it's $12 per person and $14 for the cake. So we can write both of these equations into these situations into equations. There we go. So the total cost, so we're looking at $8 per person or per child plus $30 will equal the total at Chuck E. Cheese. Chuck E. Cheese. And the other one, Taco Time, it's going to be $12 per child plus $14 for a large cake, and that equals T. Now you can see that both of these are, neither one of these is in standard form, so we need to change that. So we're going to do that right now. First of all, this 8C plus 30, 8C plus, wrong color. 8C plus 30 equals T. Let's put this into standard form. I am going to, first of all, subtract 30 from both sides, and I end up with 8C equals T minus 30. And then I have to subtract T from this side because I got to get both my variables. And that cancels out. Those canceled out, now these cancel out, and I get 8C minus T equals negative 30. There's one. Now the Taco Time. 12C plus 14 equals T, so I'm going to subtract 14. Those cancel out, and I'll have 12C equals T minus 14. I have to subtract T from that side and that side, cancel out over there, and I end up with negative 14 and 12C minus T over here. So now I have two different equations in standard form now. So 12C minus T equals negative 14 and 8C minus T equals negative 30. Now, I have decided I want to get rid of the variable t, but you can see that they're both negative, so one of them has to be turned into positive. So I'm going to change everything in the second equation. I'm going to multiply by negative 1, and when I do that, those will all change to their opposites. So the top equation is still 12C minus t equals negative 14, but the bottom equation will now be negative 8C plus T equals positive 30. So now the next step would be to combine those two equations, because now I can get rid of the T variable. When I combine these, positive 12 and negative 8, I get 4C equals negative 14 combined with positive 30, that is 16. If I divide both sides by 4, those 4's cancel out, and C is equal to 16 divided by 4, which is 4. So 4 is the number of children. All right, now I can figure out the cost because I can go back and substitute that in. So let's use Taco Time since I can see it right there. 12C plus 14 equals T, right? C is 4, so it'll be 12 times 4 plus 14 equals T. 12 times 4 is 48, plus 14 equals T, and 48 plus 14 is 62. 62 equals T, so T equals 62. So the cost is 4, and the total is 62, not the cost, sorry, the number of children is 4, and the total cost is 62. That's when the cost will be the same for both places. Solving systems of equations in real-world applications. You're welcome. Now, of course, we would want to check to make sure that is correct. So using step 5. But in the interest of time, we're just going to say, yep, we're good. But I always want you to check your work. Now, here is your practice for lesson 7.3.5. 4 systems to solve, and one of them involves a story problem. Nice job. Have a great day. Don't forget to be awesome. See you next time around.